So, like I was introduced, I'm Jerod Johnson. I'm a technology evangelist for CData Software, a leading provider of data connectivity solutions. You can find me on Twitter. It's not very interesting. You can find my company on Twitter. It's a little more interesting. So I'm here today to talk to you about why standards-based drivers offer a better API integration solution. So I'll start with talking about the state of data today. So what does it look like to be a developer working with APIs? I'll talk about the different options that developers have for working with those APIs. I'll talk about data APIs, which is how standards-based drivers expose data. And then I'll end with a short case study of a company that's using standards-based drivers to complement their connectivity solutions. So the state of data today, wow, that picture looks familiar. So Karthik already went through this. There's over 200,000 published APIs now. There we go. So a piece that he didn't have was the fact that modern enterprises are using at least 16 SaaS applications, that means 16 APIs that developers need to integrate with. And then on top of that, they're using dozens of on-premise or private data stores that are also behind APIs. So a study by Better Cloud 2 years ago was saying that SaaS is now the system of record. So more companies are using SaaS applications than companies that are not. Based on the data that they presented, we can easily say that 58% of companies are running almost completely on SaaS. So running 80% or more of their data from SaaS applications instead of on-prem or local data sources. So of those companies, 34 SaaS applications are being used, which is over double the average company. So imagine as a developer, you're writing an application that needs connectivity to 34 or more APIs. So that presents a problem. And there are different solutions for integrating with those different data sources. The first of which is direct integration. So you as a developer, you work directly with the API. So you're making the HTTP requests, you're making protocol level requests within your programming language to get data in and out, push data, pull data as needed. The next option is software development kits, which is, as you guys know, development library that essentially wraps around the API. So it abstracts it a little bit, but still offers you somewhat direct connectivity, especially within your programming language. The third option is integration middleware. So these are your ETL solutions, these are ESBs, these are API platforms, a system that aggregates data or extracts data into a single point of contact. And then the last option as we see it is standards drivers. And what are those? Well, we'll get to that. So for each of these, I'm going to talk about kind of the benefits and the considerations. So what's good? What are things that you need to think about? And we'll go through the line. So for direct integration, one of the benefits is you're going to get the greatest control. So you're looking at the ability to specifically work with those API endpoints that you need and ignore the rest. So you're not forced to implement things that your application doesn't need access to. You're not forced to develop against parts of an API that your organization doesn't need. And with that, you get simplified integration. So there's no overhead, there's no mask around the data, there's no wrapper. You're talking directly to the API. You know exactly what you're doing. You know exactly what you're getting. You know exactly how you're connecting, authenticating. You have full control over security. Some of the considerations when working with direct integration is you're often looking at the longest time to integrate, specifically if you are developing against multiple sources of data. So imagine you're doing a direct integration with the Salesforce API, and then the Marketo API, the HubSpot API, the Google BigQuery API, the Google Drive API, and this goes on and on and on. So each of those is going to take time to implement. You're also looking at lifetime maintenance of those integrations. So as the API changes, you as the developer are responsible for updating your application to ensure that your application is up to date, has full functionality, is offering everything that the API offers. And you're looking at limited reuse across data sources. So as you develop against these APIs, you as a developer or your development teams are learning new skills. They're learning shortcuts, tricks of the trade, best practices. Well, the best practices for the Salesforce API may not be the best practices for the HubSpot API. They may not be the best practices for the MongoDB protocol. So they're having to learn new ways to connect with data as they go through. So software development kits, like I said, these are software libraries embedded within your application. It basically builds a wrapper around the API. So one of the benefits is you're getting tightly bound data access. So all of the classes within the library, all of the methods within the library are bound to the API and developed in a way that makes sense for that API. So it'll be something that's familiar. The structure of the SDK will be familiar to you as a developer. It'll be familiar to your development teams, which makes it easy to work with. And again, you're getting that same kind of simplified integration. So you only have to implement those pieces of the library that you need. You have full control over connecting. You have full control over who authenticates, how it's authenticated, and the list goes on. Things to consider. With SDKs, you may be looking at a lack of a shared data model. So I harp on CRM because it's one of our more popular use cases, but an account in Salesforce does not look exactly like an account in HubSpot, which may not look exactly like an account in QuickBooks. So every time you implement, you're looking at implementing a different data model. You may run into limited vendor support. So as the SDK updates, it may deprecate API functionality that you needed, or it may change the way that it implements certain API functionality, which again puts you in a spot where you need to go back, update your application with the new SDK instead of getting backwards compatibility with the current SDK that you have. And again, you're looking at limited reuse across data sources. So you're running into the same problems where implementing one SDK may not translate into implementing another. So it's something worth considering. So the next option for integration is integration middleware. One of the benefits is it's going to abstract that data connectivity. So your developers don't need to necessarily know the ins and outs of connecting to Salesforce. They don't need to know the ins and outs of connecting to Google BigQuery or MongoDB. So the integration middleware is going to manage authentication. It's going to manage security. It will have control over which accounts are able to connect, which data points are accessible from the platform itself. And with a lot of these, you're going to see a shared data model. So the Microsoft Common Data Services, I think is what they're calling it now. It was Common Data Model at one point, and I think they keep going back and forth. That's an example of the shared data model. So within some platforms, an account will be an account will be an account. So your account from Salesforce is going to look exactly like your account from Marketo, is going to look exactly like your account from QuickBooks. So that offers, there's a lot of benefit when you're integrating in that way. Considerations with working with integration middleware, some of the platforms can be expensive, and even the ones that aren't expensive can be complex. So are you working into your budget the cost associated with the API platform? Are you working within your manpower, somebody to manage that platform itself? So who is going to control those connections? Who's going to authenticate different users? It's worth considering. Another consideration is vendor lock-in. So your developers have integrated against a specific API platform. Something about that API platform changes, and now you have to make a decision. Do we continue using with this and rewrite our application, or continue working with this and implement those new changes, or eat the new costs if it gets more expensive, for instance, or do we go with a new platform and then go back and change the application anyway? You often have the least developer control when working with an API platform, so the platform will expose the API the way that it exposes it, so your developers may not be able to get necessarily the information that they want. And then oftentimes you run into limited data source integrations. So as your enterprise is growing, you're working with data from more and more data sources. Well, a single API platform may not offer integrations with all of those data sources. So something else to consider. So what are the benefits and considerations for working with standards-based drivers? Well, before we get into that, I think it's worth talking about what a standards-based driver is. So a standards-based driver, these have historically been used to integrate with databases. So we're talking about technologies like JDBC, ODBC, ADO.NET. So the libraries, the drivers that exist that talk to databases. As APIs have grown, as more and more companies are taking on SaaS applications, the way that businesses work with data is changing. So back in the day when you were working with data, it was coming all out of a database or it was coming all out of a flat file. Well, that's changing. So now you have your data in a database, you have data in flat files, now you also have data in SaaS applications. So companies have jumped on this. So NetSuite has an ODBC driver that you can get data from. MongoDB, they've made their own ODBC drivers. They've made their own ADO.NET providers. Google BigQuery has ODBC drivers. So they're offering database-like connectivity that is familiar to developers and familiar to data-centric organizations to things that aren't databases. So standards-based drivers, the benefits and considerations. One of the benefits is there's a low learning curve. So standards-based drivers are designed to talk to databases, which means that they use SQL. So now your developers only need to know SQL in order to get data from the different data sources that their applications are connecting to. Because it presents a relational model, a database-like model of the data source, it's self-documenting. So you can look at the list of tables and know essentially what API endpoints exist. You can look at the columns within those tables and know what fields are exposed. And you get that common data API of SQL. So you're writing queries to get data in and out instead of having to implement a specific API request for the different data sources that you're working with. And for most standards-based drivers, you're going to be insulated from those API changes. So as an API changes, it's still going to look like a database within your application. So the vendors that are creating these drivers will implement the API changes essentially in the back end, but on the front end, you're still writing SQL queries to get to the data. So some considerations. They're not going to be suitable for event-based applications. So if you're looking at streaming, if you're looking at IoT, if you're looking at event-based operations, so if this then that, thinking about things like webhooks, the database model doesn't make sense there. And so a standards-based driver is not going to be the solution that you want to go with if that's the kind of connectivity that you need, if that's the way that your application is consuming data. And another consideration is there's an additional layer of abstraction. So if you go direct to API with that direct integration, right, you have your application and then the code and then the API, and that's it. With direct drivers, with standards-based drivers, you're going to have the application, SQL, the driver, and then the API. So there's an additional layer there which can offer some overhead and performance, and it may abstract data in a way that doesn't work for the way that your organization is building your application. So data APIs, this is kind of how standards-based drivers are going to model data access through SQL. Tables and views are going to be exposed, they're going to expose those resource collections. So if you have resource collections like orders, accounts, pages, users, if something is read and write, it will look like a database table. So you'll be able to select, insert, update, delete. If it's read-only, it's going to look like a view. So you'd only be able to select from that. The individual elements in a resource collection, so an individual order, an individual user, an individual page, those are going to correspond to rows within the table. So as you can see here, we've got a select query. So I'm selecting from my Salesforce accounts all of the accounts whose billing state is like Texas. So these are different accounts direct from my Salesforce instance that have a billing state of Texas. Another thing about data APIs, the standards-based drivers, they're going to expose sub-collections, those relationships, in a way that maintains them. So the relationship that exists between orders and order line items, the relationship that exists between, say, a Facebook post and the comments on that post. Within the API, there's typically some field or some key that maintains that relationship, and that will get exposed like a foreign key in a relational database. So CRUD operations, so your create, read, update, and delete, those operations are translated to SQL statements. So if we're working with a REST API, you're looking at an HTTP GET that becomes a select. HTTP put, post, and merge get exposed as insert and update, and then HTTP delete. Anybody want to take a stab at what SQL statement? Delete, yeah. super unintuitive. So the one thing that gets weird when you're working with a standards-based driver trying to build a database model of an API is that APIs have all of these operations and functions that don't really act like tables. They don't look like tables. Something like downloading an attachment or uploading a document, generating a report from Salesforce, for instance. These operations are going to be exposed as stored procedures. So you would be able to call an execute SQL statement to execute the download attachment stored procedure and then pass parameters to make sure you're downloading the correct attachment, working with the right data to get what you need. So these data APIs that exist because of standards-based drivers are going to simplify developer integration. So we're using .NET as an example over here on the left. So if you're working with C# and you're used to talking to a SQL Server database, you have things like SQL connection, SQL command, SQL data adapters, SQL data reader, and so on. That functionality basically gets extended as new classes with similar names. So you'll have a Salesforce connection. You can create a Salesforce command. You get the Salesforce data adapter. And then from there, your developers are working with live Salesforce data just like they would work with database data. So they can create their queries, fill data tables. You can fill grids. And this extends, so this is .NET using the ADO.NET providers, but that's going to extend to the same kind of database connectivity, database functionality that you're used to when working with databases in Java or Python or R, whatever your development language is. And then the standards-based drivers are going to typically adhere to one of the specifically defined flavors of SQL. So SQL 92, for instance. So anything that is used to consuming or creating SQL 92 queries, any developer that's familiar with the SQL 92 standard is going to be able to talk to any of the data sources that these standards-based drivers support, including complex queries like joins and aggregations. So you can see here we're getting some information about our accounts and the opportunities attached to those accounts. I'm joining two API endpoints as if they were database tables based on a relationship that's defined within the API. You can do aggregations, so I want all of the annual revenue by state. I want to know the average annual revenue by state. I can create a query like that. And then, updating, you can update specific elements within a collection. So one of the things that's worth noting is that the standards-based drivers are often going to push this complexity down to the server. So you're not looking at client-side processing, you're looking at server-side processing. So wherever it's supported, if the relationship exists within Salesforce, the driver is going to ask Salesforce to collect that data, to join that data on the server side, and then the only data that gets streamed back is the data that's already joined together. And aggregations work the same way. So if Salesforce supports aggregating data, then the driver will support that as well. So these are leading providers that are using data APIs. So these are customers of CData Softwares that are implementing standards-based drivers within their tools. So companies that are already doing this, BI, ETL, data integration platforms, virtualization, data warehousing tools, all of them are already doing this. So they're taking all of the APIs that they support and easily integrating with them using those standards-based drivers. So a case study, Bouquet.ai has a natural language AI platform called Eris that is able to take natural language queries and turn them into SQL queries. So they got their start by being able to use natural language to query database data. So instead of having to write all of this, you just ask, what is the win rate for all opportunities by industry? What their platform does is takes that question and turns it into a SQL query, which then could go direct to a database, get the data out, return it as a result set that can then be processed as in a BI tool to create a chart, or in an application to create a table as needed. What Bouquet.ai approached CData for was to extend that functionality to all of the data sources that the CData drivers support. So now somebody could ask Salesforce, what is the win rate for all opportunities by industry? The SQL query is still generated, But instead of Bouquet.ai having to implement the SQL query to API request translation to get the data out of Salesforce, the driver does that. And so that extends to any of the data sources that we support. So real quick, what's the takeaway? First and foremost, every business is going to choose the integration solution that makes sense based on their current, future use cases and their time and budgetary restraints. And so any of the integration solutions are options that exist. One thing to consider is the role that citizen analysts and integrators and third-party tooling may play. So standards-based drivers offer out-of-the-box connectivity to those tools and platforms. So it may be worth considering using that to integrate as you go. So I just encourage you to explore data-centric integration based on established standards. Thanks.